All right, so we are going to start working on the eye. So the first thing we're going to do is please make sure that this part, the little visual nerve or optical nerve is over here, and the front is over here to the left. All right, so the first thing we're going to label is the cornea. Now the cornea is a clear glass-like layer over your eyes, in parentheses, iris and pupil. It is the only exposed part of your eye. Okay. Now, your cornea is what you touch when you put contacts in. If you touch your eyeball right now, that's your cornea. That's it. Anytime you touch it, that's your cornea. Okay, in LASIK surgery, they literally cut a little insert and then they pull it up over and then they go in. They go into your eye via your pupil. It is really important that you understand the pupil is not a thing, it's an absence of a thing. It's a hole. Okay? It is a hole in your iris that allows light to enter your eye. Okay, so the pupil is literally a hole. There's nothing there. The iris, which is going to be written right here, the iris is the colored part of your eye that is made up of muscles that constrict or dilate your eye. Controls the amount of light entering. Okay, so your iris is the colored part of your eye. So please do exactly what I do. I promise it'll help. Alright, so I'm going to take a color from my box. It doesn't matter what color. I'm going to make mine blue because I have blue eyes. Okay, so the iris is located right here. I have blue eyes, so I'm making it blue. It really does not matter. Okay, so here are my iris. I'm just going to underline it and draw the lines so you know. The iris is the colored part. The pupil is what allows light to enter and exit. The pupil is the absence of a barrier. And that's exactly what it is. So I'm just going to make a light stream, which we're going to extend once we get going here. Okay, so your pupil is literally a hole into your eye. So during LASIK surgery, they cut underneath where your actual eye is, like where your iris is, the colored part. They cut underneath it, and then they pull back your cornea. With the cornea being completely peeled off, all they have to do is they just take like a little stick, obviously not like a wood stick, and they just relax the muscles, and that's how they enter your eye, is they go through the pupil. They just kind of like swirl it around and eventually relaxes. Then it's big enough that they can cut a slit into your muscle and get to your lens. Your lens is immediately behind your iris. It's immediately behind your pupil. What is it? It's not piece of light, but like, you know, every light wave, there we go. Every light wave has to go through your lens. Your lens focuses and flips the image upside down to make it easier. For the retina to process. Okay, so for me, because I have different color, I'm going to make my lens a different color blue, but a blue nonetheless. You can use whatever color you want, it does not matter. Okay, so this is your lens. Okay, so technically, when you look into someone's eye, and you are staring off into their eyes, you're actually not looking into their eyes, you're looking into their lens. Okay, because that's on the other side of their cornea. Goes cornea, then where the pupil is, and then hits your lens. Alright. So, just to review. Your cornea is the glass-like outside of your eye. Okay? Then you have your pupil, which is nothing. It's an absence of something but allows the light in. Around the pupil is your colored part of your eye. And if you look into someone's eye, I mean, you're not going to actually see it, but you're looking immediately into their lens. This is a little intimate, but we're going to do it anyway. You are going to turn to someone near you, and you're going to just look into their eye. Just so you can kind of see. It's a little intimate, I'm not going to lie, I understand that. But turn and look at the person next to you. You're going to have to get kind of close. So turn and look. Go. Turn and look. Don't be weird about it. Don't be weird.
Just looking into the eyes.
Okay, guys, if you look at the irises is the colored part. And I'm not super close, but I'm close. If you look, you can see like different shading of color. That's just different muscles, which is pretty cool. It's really cool. Huh? Sure. Ew, that's kind of creepy. Alright, so yes, a little intimate. Don't worry, we're going to come back to the intimacy of looking into people's eyes here in a little bit. So, okay, so we have the cornea. I'm trying to go here. We have the cornea, which is the glass-like. It allows light to enter freely, goes into the pupil, which is surrounded by the iris, which constricts it or dilates it. The light goes through the lens, and it's flipped upside down and sharpened. Have you ever looked at something and then quickly looked at something else, and it took you a second for it to like become clear? Yeah. Okay, that is your iris, your lens shape, twisting, tilting, doing whatever it needs to do to make it easier. Like, for instance, if I take off my glasses, okay, everything is blurry, and then if I look at it long enough, eventually it will sharpen, and then it falls right back to right here. Then it sharpens, and then it falls right back to chaos, okay? So, that is all by your lens, right, Chris? Yeah, okay? So, the next major thing on your list is the vitreous, V-R-E-O-U-S, humor, which is all the ushy-gushy stuff in your eye. If you popped your eyeball out of your socket and you went and squished it, it would burst, like a donut, like a jelly donut. And it's filled with the vitreous humor. It supports, no, it's clear. It supports the structure. Huh?
Is that a C or O?
R-E-O-U-S, humor. It supports the structure of the eye. Okay, it literally just, it's like clear jelly that kind of, have you ever seen like little specks kind of float in like your eye and stuff? It looks like there's like fairies. No? Okay. Because they get really like shimmery for me.
Is that like when you like close your eyes?
Like if you like rub your eyes.
White spots?
No, that's just because you messed up. Have you ever just like staring and you just catch little glimmers and stuff like floating? Yeah, okay, yeah, I'm not crazy. It's a thing.
And then you turn your head and it's like you can see the light moving.
No,
It's
it's
like
something else.
you close your eye like a little squiggle.
Yeah, it's like a little squiggle. If you've ever seen like little squiggles like floating in space, it is actually not in space, it's in your eyeball. It's the vitreous humor has like kind of like clumped and it's just like floating through, and as the light's coming in, it get caught in it, so it deflects the light, and that's why you see things like floating. No? I got you, girl.
Pixies.
Yeah. Yeah, it looks like you have like fairies watching over you. Huh?
They don't look like fairies.
No, I know, but it's like little stuff floating in the air that no one else sees. So it's like
Yes.
fairies.
Yes.
Yeah, I thought it was cute. Whatever. All right, here we go. Your next thing is your retina. Now, your retina is a big deal because your retina is where transduction occurs. Okay? Anytime you see the star in sensation and perception, it means transduction occurs here. This is where transduction occurs. Light is turned into a neural impulse. Okay? So, your retina, which I am going to use red. Okay, your retina. Please watch. I'm not just coloring straight through. I left a gap over here. Does that make sense? Okay, there's a little bit of a gap here. Okay, so that is your retina. Okay? Now, the next thing is I am going to draw an X right here. Okay? That is your fova. Parentheses, focal point. Okay, so your fova, or your focal point, this is where the image hits the retina. Put everything into my drop-off box, please. Hits the retina, and this affects the image's clarity. Okay, so your fova is where your light hits. So I'm going to take my yellow. Remember how we drew light coming in? Now, as it comes through the lens, it becomes focus. So instead of it being a ton of light that's being pushed in, it's now going to be a single beam. It's now going to hit my fova. Okay, so light goes from the cornea into the pupil, which is surrounded by the iris, through the lens where it's flipped upside down and straightens forward and hits the fova, which is located on the retina. Yes. Because it's easier for your brain to process. Remember how we said the left side controls the right side of your body? It's just easier. I don't know why. It's just easier for your brain to process information. So right now you're looking at me. Your brain is receiving an image of me upside down. And then your brain flips it right side up, and that's why you're seeing me the way I am. I don't know why. It's just easier for it to do it. Okay, so as the light comes in, goes through your cornea to your pupil, which is surrounded by your iris, through your lens, and then hits your fova. Your fova is located on your retina, where transduction occurs. Now, on your optic nerve, which is what we've already kind of colored, we have something called a blind spot, which I'm going to do an experiment with you in class, hopefully on Wednesday. Okay, I'm just going to take a yellow, I'm using purple, and I'm just coloring it right here where the optic nerve enters and hits it doesn't touch the retina, but it's close. Okay, this is your blind spot. So I'm just going to draw an arrow and write blind spot. Okay, any image that hits the blind spot is not seen. The reason is because behind your blind spot, there's no retina at all. If there's no retina, can you have transduction? No. So the light's just going into your optic nerve. Your brain can't process light. It's only the retina that can process light and turn it into a neural impulse. So anything that hits that blind spot is completely gone. Okay? There's no recollection, there's no transduction, there's no processing of that image. It's completely gone. And then finally you have the optic nerve over here. In your optic nerve, this sends neural impulses to the occipital lobe to be processed by the visual cortex. Okay? Alright. And then so you have your optic nerve way over here. For me, it's going to be green. And this is just going to take information away. Your optic nerve is the beginning of your blind spot. Okay? And then we have one more to fill in, and then we're going to add a lot more complexity to this. And this is a sclera. C-L-E-R-A. The sclera, it is the eye muscle. It is the eye muscle outside your eyeball that moves your eye. Okay? So, what we're going to do right now, we're going to do the process of transduction in the eye. The first thing is the cornea. So light goes through the cornea. Second is the pupil, which is surrounded by 3, the iris. Then it goes through the lens. Then it hits the fova. Then it hits the retina. Okay, and we're going to put a big star here. Why are we putting a star here? Transduction occurs. However, we're going to add a little more complexity, and I'll explain what it is next. In the retina, it goes ganglion, bipolar, and rods and cones. We're going to explain what that is in just a second. Then you have your optic nerve. Then your occipital lobe. Then your visual cortex. Okay, so light enters the cornea, then through the pupil, then by the iris, then through the lens, then hits the fova, then goes to the retina. The retina is where transduction occurs. It goes on ganglion, bipolar, rods, and cones. 7, then it hits your optic nerve, then your occipital lobe, and then your visual cortex. Okay? Alright, so at the bottom, I left room. Hopefully you did too. Draw a box. Is that an Amber Alert?
Yep.
How come yours is the only one going off?
Mine went off this morning and last night.
Mine went off last night. Alright, so here we go. Okay. Draw it as I'm doing. So light hits. Retina. Okay. So right underneath the cell, you have these little circles. Then from here, it goes to 2. Then on the back, you have rods and cones. They look just like that. Don't worry, we will color coordinate them in just a second. Okay, so what's going to happen is light hits the retina. By the way, this is your retina. Okay, so the first thing it hits is your ganglion. Ganglion cells. Now these ganglion cells, okay, the second, so for me, I'm going to make them purple. So I'm going to do ganglion cells. First thing they hit is my ganglion cells. So light hits the retina. The first type of cells, or first photoreceptors, are going to be the ganglion cells. Then the second is going to be your bipolar cells. Okay, for me, they're going to be green. Okay, and these are these little dots here. Okay, then it hits your third layer. So there's 3 layers. First is bipolar, ganglion, then it goes bipolar, then it goes third. You have rods and you have cones. Okay, rods see black and white. Cones see color. Color starts with C, cones start with C, cones see color. Okay, so cones, color. Okay, so rods are going to see black and white images while your cones are going to pick up color. So the fact that you can see that this highlighter is yellow, your cones are telling you that. The fact that my sweater is black, your rods are telling you that. So for me, my cones are going to be red. And the cones look like cones. That's why they're called cones. And rods look like rods. That's why they're called rods. Okay? Now, technically, the very back layer after your cones is your retina. Then it's actually processed by your retina. So the fourth step is transduction on the retina. And that is right here. Okay, so when light comes through your cornea, goes through your pupil, light goes through your cornea to your pupil, which is surrounded by your iris, goes through your lens, flips upside down, hits your fovea. Okay, fovea is on the retina, so then technically it hits your ganglion cells, bipolar cells, rods and cones, then your actual retina. And once it hits your retina, it's now a neural impulse. Then it goes to your optic nerve, your occipital lobe, and then your visual cortex. Okay? Does that help? Doing a little drawing, does that help?
Yeah.
All right, your enthusiasm today is overwhelming.
Glad I could go
All right, guys, what I would like you to do is you can put your color pencils or crayons away on your desk. How much time do I have, please? 10 minutes?
2 minutes.
2 minutes? Perfect. Transition quickly to your study guide or your focus, please. We are going here. We don't have time to waste.